Hello and welcome back to my video series on how to learn Fusion 360 for your Glowforge. My name is Jason Lichtman and I'm happy to be your host today. This is going to be webinar number 4, and as you can see in the background today, our background's slightly different. It is still the Autodesk office here in Denver, Colorado, but I'm going to be in a private room today so that our audio quality is exactly what it should be versus our previous webinars that were not so great in audio quality. Also, this is not live. I'm not hosting this live right now with multiple attendees. This is being recorded so that again, the audio quality and the video quality will be better for you guys. So just wait for this to be posted momentarily. Today, our topic is going to be sheet metal tools and living hinges. All right, so we're going to focus on that topic alone, nothing else. I hope you enjoy it. A little bit about me again, in case you don't recall or haven't watched any of our other videos. My name is Jason Lichtman. I'm your host. My background is in mechanical engineering. I spent my entire career designing consumer products, and that's just what I love to do, right? If you met a dental hygienist, I bet you that as they meet you, the first thing they're doing is looking at your teeth and deciding if you brush properly or twice a day or hopefully more than that. In my particular case, I look at a product and I can't help but see how it was designed and how it was manufactured and potentially how it could have been done better, right? That's the lens that I see the world through. And today I'm going to invite you to see the world in my eye, and we're going to be learning Fusion 360 together. All right, so hopefully it'll be a great journey. Let's go right into Fusion. So we're going to be working with today, like I said earlier, is going to be living hinges and sheet metal tools. This is a design that's a pretty simple box, and you could see that we have our living hinges in each of the corners, and that's what we're going to be teaching you how to design today. And we're going to start off by opening a new design and teaching you about sheet metal first, right? So the first thing I want you to know is that even though it has the word metal in the words sheet metal, it can apply to a whole variety of different things. I have an example for you actually of what you could do with it. And so if I go here to this tissue box, you could apply sheet metal techniques to a variety of products, anything that basically gets folded. So here I have a tissue box that was sitting on my desk that I modeled up for a training event here at Autodesk. And I'll show you what this would look like when it's flat. And that's really the power of sheet metal tools, right? I designed a 3D tissue box, and then our software can actually unfold it and show you what the pattern would look like. And if you cut this out and bent this pattern along these blue lines, this middle one is the center of the bend, and this is the start and this is the end of the bend. If you bent it on all of these lines, you would end up with this tissue box that you could see right here, right? So that's the power of sheet metal. And again, it doesn't apply to only sheet metal. You could use it for metal, you could use it for paper or cardboard, or today, even wood, right? So that's what's pretty cool. And so we're going to start off with a new design, and I'm going to go and turn on the origin. If you don't recall from previous webinars, the origin, this white dot right here, is really the center of my 3D world. And from the center, I have different axes. That's the red, the blue, and the green. It looks like lines, but really they're axes. If you ever have trouble remembering which one's which, think about it this way. RGB, X, Y, Z, right? So anytime you see RGB, X, Y, Z, I want you to think about it that way. R is the X, G is going to be the Y, and blue is going to be the Z. That's easy to remember. And so we're going to start off by drawing a simple rectangle. And I'm going to try not to use any keyboard shortcuts. Instead, I'm going to go and use the tools the old-fashioned way. And so I'm going to go under Sketch, Rectangle, 2-point rectangle, which also happens to have this keyboard shortcut R if you'd like. I'm going to draw a simple rectangle, and then I'm going to go into our sheet metal environment. And it doesn't matter if you were already in the sheet metal environment or you do it after, it's really all the same. It changes the tools that I have on top, and I'm going to click Flange, that's this one right over here, Flange, and then I'm going to choose this rectangular piece. Now, the first thing it's doing is it's going to ask me, is the thickness of this part, let's look at it from the really good front view, is the thickness going up on side 1, or is it going down on side 2, or is it symmetric about the center? I personally think side 1 is perfectly fine, so I would just use side 1. It asked me if I'm going to be making a new body or a new component. I'd start off with new body. And if you don't know the difference, the difference between a body and a component in Fusion 360 is that a body is fixed in space. It can't move on its own. You can use commands to move it, but you can't just click on it and drag it off into space. Whereas a component can be moved into position, right? So there's a lot more positional awareness for a component. And I think that it's easier to start off as bodies and convert to components when you need to. So that's what I'm gonna do. And then here I have sheet metal rules. And these rules are gonna govern what the thickness is of the material, how tight you can bend it, right? Because like a thicker metal is gonna bend in a much bigger radius than a much thinner metal, you know, or even paper, you can actually crease it into really sharp edges. So all of that kind of thing is going to be within your sheet metal rules. And I already have one here called proof grade medium walnut ply, but I'm going to show you how to create that in just a second. For now, I'm going to cheat and just use the one that I already have. And so here I have a sheet metal flat rectangle. Super boring, nothing special about it. Where it gets interesting, though, is where you can actually create flanges, right? So we have other different tools, right? Other CAD packages or competitors mostly let you have different tools for different kinds of flanges you're going to make. In Fusion, it's really just one flange tool that does pretty much anything you'd ever want. So I'm going to use this tool a lot, and I'm going to click on it right now. And when I pick on an edge, I want you to see what it can do. I can click on an edge and then drag the arrow, and it can create this wall. If I hold, I'm going to do it right now, so you can't see my fingers, but if I hold Control, it's going to get rid of the preview, but it's going to allow me to pick additional edges. So I'm going to pick this one right here, and I'm going to let go of Control. And now you could see that I have two edges that are both extruded, and the shape in between looks a little funny. That's called mitering, right? And if I turn mitering off, you're going to see that there's a slight difference. I'm going to zoom in there so you see that again. So if I go like this and zoom in, and I turn mitering on, the parts kind of try to join closer to each other. And how close they can get to each other, that's based on the sheet metal rules that I haven't talked about setting up yet. But I want you to know that generally that's how it works. Now I'm going to turn mitering off, and I'm going to zoom out a little bit. And I want you to also see that you don't have to just do straight vertical walls. If I change the angle, and I could type in a number right over here, or I could just rotate this bar, now you could see that I could change the angle of my flange. Okay, now with mitering off, it doesn't look that interesting, but when I turn mitering on, poof, you're going to see that the actual walls try to join up with each other, and that's where you're going to get really interesting things. Right, so this is one way you can create sheet metal objects. There's another way you can create sheet metal objects, and right now, by the way, I'm giving you generalities, and then of course, I'm going to jump into some of the details so you could follow along with me. I'm going to create a sketch over here. I'm going to create a sketch, and I'm going to draw a line. I'm going to go under Sketch, Line, and I'm going to draw a line that's kind of long over at this angle. I'm going to hit Escape. All right. Now what I'm going to do is I'm going to try the Flange tool again, and this time instead of picking this edge and dragging it into a particular direction and length, I'm going to use this line to guide it. So I'm going to click Flange. I'm going to pick this line, and then I'm going to pick that edge that's adjacent to it, and it automatically is creating a flange using that line as the length and the direction, and it joined it with that edge. And that's pretty cool, right? Now, one thing to note in both of the flanges that I've already created is that this radius that you see here, that one, as well as the ones from before, those radii are controlled based on the sheet metal rules. So this is a great time for me to jump in and show you sheet metal rules and how to set them up. So I'm going to go under Modify, Sheet Metal Rules, and here I'm going to have a library of basic sheet metal rules that come standard, except this last one because I made this one just a few moments ago. And I'm going to right click on one of these and say new rule. That's how you'd set a new one. And when I pick the new rule, the first thing I should do is pick what it's called, right? So the one I just made a few moments ago was called Proof Grade Medium Walnut Ply. Let's pretend for a moment that I wanted to this time do Proof Grade Medium Cherry Ply. Okay, there are really, I would say, two things that are important to set up on your sheet metal rules. The first one is going to be the thickness. This should be accurate. So I want you to take a pair of calipers and measure the thickness of your ply. And if it's 3.14 or whatever, type in exactly 3.14, right? If, by the way, you're using imperial system, you could type this in inches. I happen to be using metric, which is why it's all millimeters, but you know, whichever one works for you is fine. And then when you go to bend conditions, it'll have here bend radius, and you can set the bend radius, like the minimum, to be, in this case, the same as the thickness of the material, but you could also pick a particular number. So maybe it's 25 millimeters as your minimum bend. Now, in truth, we're not going to really use this very much, but I do want you to see how it impacts the results. And so I'm going to save this. Right now we have Proof Grade Medium Cherry Ply. I'm going to say close. But remember that when we made our first flange, that first rectangle, we had to choose which of the sheet metal rules we were using, and we chose the medium walnut ply. So over here on the top left, that's where that's selected. And if I wanted to switch the rule, all I have to do is hover here and say, this time I want to use the Proof Grade Medium Cherry. And notice that the bend changed quite a bit. And it changed quite a bit because although the thickness is the same for my cherry and my walnut medium ply, the bend conditions for the walnut was set to equal the thickness of the walnut, whereas the bend conditions for cherry were set to 25 millimeters. And you could see that the bend is much bigger now. And this is what happens when you're creating your flanges, you're letting the software automatically pick the radii. So if I look at my sketch that I used just a few moments ago, this one, I didn't have a radius in here. I just had a straight line. And it knows that this sharp corner is going to have a radius equal to the minimum radius that I have in my sheet metal rule. And in our case, 25 millimeters was used, right? Now, if on the other hand, I want to change this design, I could do that. So I'm going to delete that. I'm going to draw a new line. And then this time, oh, and sorry, I did exactly what I didn't mean to do. I used my shortcuts. So let's delete that and do that again. I'm going to go under Sketch, Line, and I'm going to draw a line. Perfect. I'm going to hit Escape so I don't keep drawing more lines. Then I'm going to go under Sketch, Arc, 3-point arc. And I'm going to choose to start the 3-point arc there and end it right over here. And right now, you could already see that this icon there is a tangency icon. It automatically set that this arc and this line are tangent to each other. But if that didn't show up, all you'd have to do is pick both the line and the arc and then choose tangent over here in the constraints, and it would add this icon and make them tangent. In this particular case, I want this line and this arc to be tangents. I'm going to go and select them and hit tangent, and now I have tangency. When I hit stop and exit out of my sketch, I'm going to get a big error because the flange that was using the previous sketch, that sketch disappeared. So I get this red icon, and that's fine. I'm going to right click and say edit feature. And this time, I'm going to have to reselect my sketch. So I'm going to pick this sketch. I'm going to hold Control, and I'm going to select this edge. And now it's actually going to use the exact radius that I put in my sketch. So if I go back and edit my sketch, and I say that this radius is, instead of 22, is going to be 10, when I hit stop, it's going to update and be exactly 10. I'm going to show you this one more time. If I make this 5 millimeters, and I hit stop, it's going to make it 5. Now this is the type of radius that I think is most useful for laser cutting. Now I wanted to show you how it does it automatically if you don't spec a radius. It uses the sheet metal rule so that you understand how it's doing it. But again, I think that creating your own radius that you get to control is way more valuable to you. And so in this particular example, I drew a line with an arc and added it to an existing rectangle. But we can actually delete all of this and start again, and I'll show you how to do it a different way where you can just draw a sketch and use that sketch to create your flange. So let's do that together. I'm going to click on my features down below. I'm going to highlight all of it and hit delete. So basically now I have another fresh file, right? Except that my sheet metal rules are already in place. So that's handy. So we're going to come over here and we're going to draw a new sketch on the top plane. I'm going to create a sketch, and this time I'm going to draw, I almost did my shortcuts. Sorry guys. I'm going to hit sketch line. I'm going to draw a line like this and a line like this, and I'm going to draw another one at another angle. And if I go and hit flange and I pick this line, I can actually, remember before we drew a rectangle and we said turn this rectangle into a piece of sheet metal, and it did it in the thickness that was perpendicular to the way that we drew it. This time, because I'm drawing an open sketch, and closed meaning like, you know, it was a full rectangle, now I have like 3 sides. It's not a full closed object. When I go to create a flange, it wants me to drag it in a particular direction. And I could drag it up or I could drag it down. And just like before, if I look at this from the side, I can choose, do I want the thickness to be on side 1 or side 2 or symmetric? So whatever works best for you is totally fine. It doesn't really matter. I could also choose, do I want to drag this thing down or up or symmetric about wherever you drew it. So that's fine too. These are really just options that are at your disposal. One thing I want you to notice though is that in this case, I drew this sketch and I drew sharp corners, but it's going to automatically try to fillet those corners with the bend radius from the sheet metal rules, right? But I want to control the exact radius. So what I'm going to do is I'm going to hit cancel. I'm going to go and edit my sketch. It's already open. And I can go and create sketch, fillet, and I can pick a fillet here and a fillet here and get an exact number. And I can control that. And then when I say I want to create a flange, it's going to use that exact radius. And that's awesome. That's exactly what I want. So everything that I showed you so far was really just to help you understand different options and techniques. This is the one I want you to use, right? This is the one that rather I recommend you use. You could do anything you'd like, right? So this is the technique I use for myself, for example. Now, let's say we wanted to design the box, right? So the box is going to end up being closed. But I should warn you that if I close this sketch, let's delete it, and I'm going to edit my sketch, and I'm going to add one more line, and I'm going to close it entirely, right? Now, when I go to create a flange, the type of flange is very different. This is not what I wanted at all. So what I want you to know is that you cannot, if you want to use this technique, you cannot close the sketch. This is one of the few cases where an open sketch is ideal. What you can do is cheat. And there are not a lot of times in life that cheating is okay. This is one of them that cheating is perfectly fine. So I'm going to show you how to cheat. So we're going to start off. Here I have my sketch, and I'm going to go and edit it. Sorry, we're already editing. I'm going to look at this from the top view, and I'm going to take this line, and I'm going to drag it. I'm going to say that this is forced to be vertical. Then I'm going to draw, almost did my shortcut, a line like this. And then I'm going to draw another line from the other side. Where is it? Line. There we are. And here's my trick. I'm going to say that, and I did a shortcut. I'm going to say sketch dimension, and I'm going to put a dimension between these 2 points. And I could make it really, really small. As long as it's not 0, they're not touching, right? So I can make it really small, which keeps this sketch as an open sketch, even though for the most part to everyone else it's going to look closed. So for now, just to keep it visually obvious, I'm going to put this as 5 millimeters, but this, realistically should be like 0.1 millimeter, something really tiny, okay? And then I'm going to say I want this line and this one. I'm holding control to select both. I want them to be collinear. I want them really to be the same line. Perfect. Then I'm going to go and create a fillet on this corner and hit enter. Now I want the fillet on the top two and these bottom two to be the same. That's my preference, but whatever it is that you want is fine. I'm going to delete this dimension and I'm going to select this arc, hold control and select this arc, and I'm going to say over here I want them to be equal. So now they're all equal to each other. Then I'm going to go and apply some dimensions to our box. Maybe it's 100 millimeters wide, and maybe it's 100 tall, or maybe 75 tall. Whatever dimensions are good for you, work fine. This is really just trying to teach you technique anyway, right? And I'm going to hit escape, and we're going to create a new line. I'm going to say I want to make a line. And when I drag this point to start the line near the middle of this one right here, notice that bluish triangle that shows up. I love that. That's going to be a midpoint constraint so that when I click here, no matter what I do with this line, this here is going to always be in the center of that line, which is perfect. And I'm going to take this thing, I'm going to drag it across. Now, notice, by the way, that this line really split up my object. So when I hover over the bottom area, it turns peach. And if I were to hover over the top area and this were closed, this would also turn peach. But because the line in the middle, the horizontal line, is really splitting my design into two halves. But I don't want that. I really want one object. So I'm going to select this line, and I'm going to go over here and say I want it to be construction, which turns it dotted, which means that it's really just used for reference. It's not used to create geometry that we're using. Then I'm going to apply another constraint. So just like I had this triangle here, by the way, if these topics that I'm saying, these words like constraints and tangency and midpoint, if those don't make any sense to you, I created a video specifically about that. I believe it's called my webinar number 00, and it's all about sketching. So if this isn't already really familiar to you, please watch that video, then come back to this. That'll make a lot more sense. I'm going to go and apply another midpoint constraint, and I'm going to select this line and then the construction line, and then this origin, and it's going to snap everything centered. Notice that everything here, except for these two white dots, turn black. And they turn black because now that I have dimensions and constraints, they can't move anymore. They are fully constrained. That's the fancy word for it. The only thing right now that's not fully constrained are these white dots, and I could drag them left. Oh, let's try that again. I can drag them around left or right only, and they're fine where they are, is the truth. I'm going to create another line to make them symmetric, right? So I'm going to say sketch line, and this time I'm going to draw a line from the origin vertically, and hit escape so I don't draw more lines. And I'm going to select this one, and I'm going to turn that into construction also, which makes it dotted. And then I could zoom in here. I want these dots to be symmetric about the middle. So I'm going to say I want symmetry. Pick one dot, pick the second dot, pick the middle, and poof, those dots turn black to tell me that everything is now fully constrained. So here I have my shape, and it's an open sketch, right? When I hover my mouse over the center, it doesn't turn, it's not peach, and it doesn't turn, highlight the outside black. This is what I want for my box design, and I think this will make more sense in a moment. So now I'm going to say stop sketch. I'm going to show the sketch. There it is. If you ever have things disappear on you, the light bulb next to the object is what's going to make you see it again. And I'm going to click the flange, and this time I'm going to pick an open sketch like I showed you earlier, and we're going to pick this sketch, and I'm going to drag it up. Perfect. And now I have the outside of my box, right? So I chose side one, and if I look at this from on top, side one in this case is like the box is going outside. So if my dimensions, if I were really strict that those are the dimensions on the outside, then I'd probably want to switch to side two to make the shape go inwards in direction. But conversely, if I chose those dimensions because I need to put something in the box, and those are really the minimum dimensions to fit the thing, then using side 1 would make a lot more sense, right? Your box is a little bit bigger, and that'll be perfect. When I hit OK, I want you to notice that these radii are exactly the dimensions used in the sketch. And that's why I think keeping an open sketch for creating flanges is going to be helpful to you, because you get to control your bending. And that's going to be important because unlike sheet metal, like real sheet metal, like metal that you're starting off as a sheet metal you could bend in almost any radius, and but the minimum is all based on the sheet metal rules. In this case, we're going to be experimenting a little bit more, and I like having more control. So this is the way I would do it for sure. I'm going to hit OK. And the next thing I want to do is I want this thing to look awesome, right? This does not yet look awesome. So I'm going to go and hit the letter. This is one keyboard shortcut I'm going to do, but I'm going to tell you what I'm doing. I'm hitting the letter A on my keyboard, and an appearance window is going to pop up. And it came up on my other screen, so I'm going to drag it over. And here I have appearances of all different kinds of materials. And I'm going to scroll down to the woods. And we have two different kinds of woods in Fusion 360. We have regular like 2D wood or solid wood, which is more 3D. And I'll tell you that the solid wood is really meant for like a big block of wood where you have an end grain versus like a top grain. And for plywood kind of stuff, like what you're going to be using realistically in the laser, I would say using the regular wood is great. Finished or unfinished doesn't really matter. And I'm going to say, you know, for now, let's work with walnut, and I'm going to drag it and let go onto my object. And here I have a quick visualization of what this kind of looks like in walnut. You know, if I really liked pine, I can come in here. By the way, these little arrows, all they mean is that you haven't downloaded the actual material properties. They're still free in Fusion. So click on any of these arrows, and within just a few seconds, it downloads it. And then you could drag it onto your part and see what this is going to look like. I happen to really like cherry, so we're going to go with cherry and stick with it. But whatever works for you is cool. Nice. Got myself some cherry. Now, the cool thing with doing this in sheet metal is the ability to flatten, right? Because at the end of the day, you know, assuming you have living hinges in all these corners, this is going to start off as one flat piece, and it's going to get bent into shape. So what you can do to be able to see what it looks like as a flat thing is going to modify, create flat pattern. And what it's going to ask you is for a stationary face. But that really is saying which is the part that's going to stay flat and everything else is going to flatten to it. So in this particular case, I'm going to choose this face right here. And then when I hit OK, it's going to unwrap everything and show me where all the bend lines are, right? So the reason that this is helpful is because I know that my living hinge is going to go between here and here 4 times. It's going to go in this area, this one where I was just drawing, and then this last one. And then I can send this file to the laser, to the Glowforge, to actually laser it, right? So that's really handy. And I'm going to exit this. We're going to go back here in a second. Now, we talked about how we have to keep our sketch open to be able to draw a flange the way that I did. And you can see that I made a really big gap over here. So the way I envision it is you're going to put the front of the box and then wrap around the back. But I do want, in the end, this edge and this edge to touch each other. And just so you could see that that's realistic, is if I hit Edit Sketch and I take this 5 millimeters and I turn it into something really small, like 0.001 millimeter, it's going to, when I hit Stop, basically look closed, right? So what you can do is start off with a really low number, and if it turns out that as you wrap it, you end up having an overlap, then you can actually expand that and make it a little bit wider. I only left it as 5 millimeters so you could actually see the gap, and I could talk about it like I am right now. In my design, I used a very small number. I don't remember what it was, but you know, 0.01, 0.01, 0.1 really doesn't matter. It just has to be small. Okay, because really your tolerance in assembling it is going to be bigger than any of those numbers anyway, so it doesn't really matter. So here I have the the outside shape. Now, to create the inside shape, and I'll do this really quickly because today's focus is not really about the top or the bottom, but I can create a sketch on the top, and I can come in here and I can actually project geometry. So I'm going to say sketch, and then I'm going to go under project and choose this one here. And I could pick this inside edge, and I can choose it for everything. Now, if I happened to have chosen when I was doing my flange that the flange direction is going out instead of in, then in that particular case, I don't even need to project anything because my sketch is the same exact geometry as projecting. Really doesn't matter. If, on the other hand, I chose to go inwards in my flange, then I definitely need to project the new inside shape because it's different than the original sketch. So I'm going to hit OK. And unfortunately, this is also not closed. And I do need it to be closed to extrude a solid object. So this is where I think having a big gap is going to visually make things easier. So I'm going to stop, and I'm going to go back to the original sketch, and I'm going to turn my gap into something big, like 5 millimeters. And I'm going to hit stop, and then I'm going to go edit the second sketch. And now when you look at it, you're going to see exactly what I'm talking about. There's the same gap that you had in the originals here too. And then I can go and add, oh, I did my shortcut. I'm going to hit sketch line and click on these 2 points, and now everything is closed. All right, so now I could actually make my gap really small again, and visually, even though this line is going to be really narrow, this is still going to be closed, and that's what I want. So now that I have this closed, I can leave the sheet metal environment because what I'm really doing right now is not sheet metal related. And I could say I want to extrude this shape, and I want it to extrude down by whatever the thickness is of my plywood. Now, here's another time where I get to introduce something cool. I'm going to hit cancel for a moment and introduce something called variables in Fusion. If I go under modify parameters, parameters in Fusion, we have a table of variables or a table of parameters. And the one that I think is really handy for Glowforge is thickness. So I'm going to create one called thickness, and this is going to be the same thickness as whatever the actual plywood is. And I'm guessing right now I don't have a plywood piece in front of me. And I'm going to hit OK. And then I'm going to go back to do exactly what I was trying to do before. So I said extrude this shape, and I'm going to do it downwards. But instead of picking a number, I'm going to say thickness, and I'm going to hit OK. And the reason I think it's really helpful to do it that way is because you're going to probably be using that same number, thickness, over and over and over again. Instead of remembering or remeasuring every time, you could just type in thickness every time you want to use that value, and then it applies everywhere. And then if you ever need to change the thickness because you went from medium ply to maybe thick ply, you could just change that value under modify parameters, and it's going to modify it everywhere. So that's super handy. I do have to go and make an edit because it looks like my thickness that I made for the top was a mess up because operation here had join, which means that it was trying to join the top with the sides into one object. And that's not what I want because really the top is one piece, the sides is another piece, the bottom is another piece. So I'm going to say new body and say OK. Now I have the gray as the top and the brown as the outside. And again, I could hit the letter A, see all the different woods that I have here, and I could just drag one into the top. So you could see, just a quick visualization of you using different, mixing and matching different woods to get different effects, doing inlays or whatever. Now, I would normally do the bottom also, but I'm going to skip it for now because we're focusing today on the sheet metal and making living hinges. And I want to show you how to create this kind of cool thing that you see right over here in this box. And by the way, we forgot to save our file, and I'd recommend saving it right away because as soon as you save it the first time, you have the ability to get autosaves. If you don't save it the first time, autosave is not going to work. So save it right away. I should have done it right away, and I didn't, but I'm doing it now. Okay, so next thing we're going to do is we're going to go and look at the flat pattern of the outside so we could put our living hinge in. I'm going to click on this flat pattern and I'm going to activate it, which is going to unfold everything. And now I have my object. And I'm going to focus in on one of these areas because we could pattern the living hinge to appear on the others as well. Okay, so I'm going to zoom in and I'm going to hit the letter P on my keyboard, which is the shortcut for project. And I'm going to project this edge. Oh, hold on, that did not work at all. There we go. I'm going to project this edge, and the top and bottom. There we go. And by the way, if you don't already know, every time you project geometry, it's going to turn it pink or magenta. So you're going to see there my pink and magenta. And if I hide the body now, I don't really need to see the wood because all I needed was really these lines, this one, the top and the bottom. And I'm going to be drawing new geometry on top. And so I need these pink to exist, but you see how everything is peach? It's like sectioning everything. I don't really want that. So I'm going to select all of these lines, and I'm going to hit the letter X on my keyboard, which is the shortcut for clicking right over there. And now I still have those same lines there, but I don't need to actually, it's not actually partitioning my area. So that's helpful. So let's go and create our living hinge geometry. And there are a lot of different geometries you can use. This is the one that I'm going to use for now. I'm going to draw a line like that. I used L on my keyboard. That was the shortcut. I'm going to do it again. I'm going to draw one from the very top and draw it down. And then I'm going to draw another one at the end. Perfect. Now notice I didn't draw the rest at all. We're going to use patterning to create the rest. What I am going to do at first, though, is I'm going to draw another line, and I'm going to draw it horizontally right over here. And I'm going to click on this line and hit X to turn it into projected geometry. And now I'm going to place it in a position, and I want it to be exactly in the middle, left from vertical, but going left to right. So I'm going to choose midpoint. I'm going to pick this point and this vertical line, and it's going to snap into position. Then I'm going to hit the letter, I'm going to click on this white dot, hold Control, and pick on this vertical dotted line and hit, I could choose midpoint or coincident. In this case, the results will be the same. Perfect. So here I have this horizontal line. And the reason it's going to be important is because I want this line, this actual cut, to be symmetric vertically, right? So I'm going to click Symmetry, pick this point, and this horizontal line, and then I'm good to go. And then what else am I going to do? I'm going to also I'm going to say Sketch, Mirror, and I'm going to choose this line, and then for my mirror line, I'm going to use that dotted line and hit OK. Cool. So here I have my shape, but I want to apply some dimensions. So maybe I want a distance from here, the top of this cut, to the top. And I could, for now, I'm going to set it as 10, but you might want to experiment. You might have way better choices than I'm making. I'm going to pick these two and say I want that to be 10 also. And now I could move these lines left to right, right? I can't move them vertically because they're really constrained by this dimension. And then this one, I want to be the same as that. So I'm going to pick this point, hold Control, click this one, and say I want it to be horizontal. I'm going to do the same thing on these 2 points and say horizontal. And now I'm looking really good. Now I do want to set a distance between this first line and the second. And I don't know what that's going to be yet, but I'm going to pick something like 3. And I'm going to hit OK. And now what I'm going to do, and this is the hardest part we're going to do today, is we're going to make a kind of complicated pattern to be able to make a lot of these. And I'm going to show you, I'm going to exit. Actually, no, I'm just going to go to the other file that I made and show you what this is going to look like when we're done. I'm going to go under right over here and edit our sketch. And I'm going to hide the wood itself for just a moment. All right. And this is the type of thing that I want to make. And so we're going to do it using a pattern, and we're going to figure out how to do it so that the spacing between here is consistent and automatic, so you don't have to go and like figure it out every time. Now, we're going to go to our other file. I'm going to click on this line and this top and bottom line, and I'm going to say Sketch, pattern, rectangular pattern is what we want. Now, when I drag this over, you could start to see that I can create my pattern. And I have some options here. I can choose distance type as being an extent, meaning like what's the furthest distance this thing is going to go. Or I could choose a spacing, which is going to say I want a certain amount of spacing from these lines to the new ones. And I could also choose how many I want as my quantity and what the distance is. That's a whole bunch of stuff. And I have a really cool way to do this that I figured out on my other design. So let's go look at the other design and then we're going to replicate it. So first I'm going to hit OK. And by the way, I could always click on this icon, double click, and I can always edit it. So don't worry about that. We can always go back. So I'm going to go back to my other file. We're going to edit that one. And here I have some stuff. So I picked the quantity as 8 in this particular case. I have the distance of, first off, I have distance type set to spacing, and distance itself is set to D122 times 2. And if you have no idea what the hell that means, pardon my language, if you don't know what that means, I'm going to tell you. So every dimension you ever put into Fusion is assigned a dimension number. So all of these have dimension numbers. And if I cancel out of here and I click on this one, and I kind of hover over it, you could see that this one's actually called D122. So earlier when I set the spacing, that one in this particular file is D122. And we're going to use that as an equation over here. We could type in, I want the distance from this set to the next pattern to be that spacing that I chose times 2. That's really the key here. So let's go back to our other file and set it that way. All right, so I'm going to come over here. First thing I'm going to do is hover over this dimension, and this one is called D4, is what it happens to be called. I'm going to go into my pattern. I'm going to choose spacing. I could pick any quantity I want for now, and I'm going to say D4 times 2. And I'm going to say, OK. And what is showing up right now looks good. Like the spacing itself is perfect, but I don't have enough of these at the moment to fill the entire width of this area. And that's where we're going to put in a second equation, which is going to automatically figure out what the spacing should be so that it automatically fills everything properly. So let's go back to our other file. And you'll notice that this spacing actually has a little thing that says fx next to it, which says that this is also an equation. So let's double click it, and this is telling me the equation. So what this equation is using is 33.144, which if you visually notice is the same distance as this width of the entire flattened hinge, divided by D118 times 2. And then this whole thing is times 1 mm. You can ignore the times 1 mm. That kind of does, that happens automatically on Fusion. The beginning is really the equation that I'm putting in. And then the question, so I'm going to highlight this whole thing and copy it. And the question you should probably ask yourself is, what on earth is D118 for this file? And if I go back to the pattern, I believe this one right here, the quantity on this file happens to be D118. Now, if your head's spinning, I'm not surprised because this is a little complicated. It took me a little while to figure out. But the benefit is that if you use these equations, all you have to do is pick a quantity and it'll automatically figure out all the spacing so that you fit that many cuts in this distance. So that's pretty cool. All right, so let's go and make that work. So I'm going to go into the other file, and I'm going to go into this pattern, and I have to figure out what this quantity is called, and this one's called D5, quantity. So now I can go to this spacing, and I'm going to paste my equation from the other file, and I believe this one really is going to be D5. And when I hit OK, everything looks all jumbled. And the reason it looks all jumbled is because we pasted the 33.144 from the other file, and that's not accurate for this one. So if I say to myself, what's the distance that I really want? Let's do another measurement. I'm going to say sketch, measure, dimension. I'm going to say, what is the distance from these dotted lines? And here, it's warning me that this dimension is going to over-constrain my sketch. Choose OK to create a driven dimension. And what that means is very simple, is that the width of that area is set based on something else somewhere else. So when I hit OK, it's going to show me the dimension, but I cannot double click it and change the number. In order to change this number, I have to change something somewhere else. In our case, the radius of the box that we chose and the size of the box, all of that's going to matter. But the result, when you flatten the box, is that the width here is 25.732. Now, this is a time where I have to tell you guys very honestly that as much as I love Fusion and think it's a great product and work for Autodesk, right, helping sell Fusion 360, like any software, there are times where you can point out things that are not ideal. And right now, when you're creating equations in Fusion, you cannot use a variable or a parameter that is a driven variable or driven parameter or driven dimension. You can't use it. And it drives me a little crazy, but that is true. You cannot use it. And so what I would like to have as this equation is I'd like to type in, instead of 33.14, I'd like to type in whatever this dimension is called and use that automatically. And unfortunately, I can't. So this is one thing on living hinges for Fusion that you're going to have to do somewhat manually, which is anytime you change something in your design that changes this number, you are going to have to come in here and change the number here. So I'm going to type it in, 5.732. And when I hit enter, now my living hinge looks awesome. Looks exactly how I want it to. Again, would this be better if it did it even more automatic? Absolutely. Am I trying to get this changed? Absolutely. But in the meantime, that is one thing you're going to have to type in manually. And you can see here that the spacing on my living hinge is perfect. If I go into the pattern and I change this from 3 to 7, it looks in my preview a little funky, but when I hit OK, it's automatically going to recalculate and fit 7 of those patterns in this space. So I want you're probably going to have to rewatch everything that I just said again, maybe twice, to figure out what I was talking about, but I'm going to try to give you a summary right now. You're going to make a rectangular pattern, and ultimately this quantity is going to drive everything. The distance is going to be set to be equal to whatever this dimension over here, the spacing, is called, and you should hover over that to figure out what it's called. So set it to, in this case, D4 times 2, okay? Then you're going to go over to this piece, and you're going to set this equation to be equal to this distance, whatever that is, divided by D5, which is the quantity, times 2. And you have to put that in parentheses. So the first thing that happens is it takes the quantity and multiplies it by 2 and takes that result and takes 25.732 and divides it by that result. This is not as complicated as it sounds, but you should watch this a couple times. It'll make more sense. The key, though, is that for you, the actual variable name might change, right? Because your file, depending on the order of you making dimensions, these letters are not going to be the same. So I want you, instead of D5, I want you to figure out what the quantity is called on your computer just by hovering over this, and you could use it there. All right, and once you set it, all you have to do is make sure that this value is input into here properly and that you choose a nice quantity, and you're going to get this to work every time, and that's awesome. Now we get to move on to the next part. So by the way, if you're just going to be laser cutting and you don't care about 3D visualization of your design, this in theory is all you really need. So you could take this thing and you could pattern it one more time, right? So I'm going to take this whole thing and I'm going to say I want to make a rectangular pattern that's rectangular. I'm going to choose to do spacing. The objects, I actually need to reselect, as it turns out, for some reason. Oh, we're going to go from faces to, you know what, this is not going to work for right now. We wanted to do a pattern of sketch geometry, and for some reason, it's not letting me right there. So I think we're going to do it differently. Let's try it one more time, actually. Sketch, pattern, objects. There we go. I'm going to choose all of these objects. And I could do them one by one. if I want. And I'll tell you, this could blow up a little bit if you end up changing like your quantity, because you're gonna have more entities. I could take this and I could choose a direction, and then I can space this out. Oh, didn't mean to rotate crazy. Let's try a front view. There we go. And if I show my body here, you know, I want this, I only want 2 of these. And then for the spacing, I could figure out what the spacing should be for this to line up perfectly. And one way I could do that, of course, is I could put another dimension, and this dimension is going to be from here to here. And it's, in this case, the number is exactly 45. So then I could go and edit my second pattern that I made and edit it to be exactly 45, and this will be in the right spot. And then I could take this whole thing and mirror it across the center plane so that I have the same pattern over here and over here. And then I could take that entire sketch, right-click on it, and say Save as a DXF, which you could then bring into Illustrator or Inkscape or Corel, convert it to an SVG, and upload straight into Fusion. Not into Fusion, into your Glowforge, right? So that would be the way you'd actually go to laser it. But if you want to visualize what that's actually going to look like in Fusion, and I think you probably do because it's cool, right? After you exit out of your sketch and refold everything, you probably want it to look like, hold on, Fusion's thinking for a second here. You probably want it to look like this. So I'm going to show you how to do both, right? Let's go back, and I'm going to undo a little bit. I'm going to undo my pattern. There we are. So this is all I need for now. I'm going to hit stop. And I'm going to say that I'm going to go into the patch environment. Now, patch is a fancy way of saying surface modeling. And this can get really complicated, but we're going to use it for something simple, right? I cannot right now in 3D modeling tools take these lines and extrude them as a cut that's like a thin cut with a certain thickness. I can't do that in Fusion. So what I'm going to do is I'm going to go to patch, and I'm going to create an extrude using this geometry. So I'm going to select all of these things. Just a moment here. And once I select all of those things, I'm going to give them a depth, or give them like a length. You'll see that in a second. And I'm going to pull it like this. And right now this warning is telling me that we're not looking at anything. I have to turn on my bodies. There we go. So now it has a length. And we're going to say I want to do this symmetrically about the center line. So it goes all the way through my wood. Perfect. And I'm going to hit OK. But I want you to know that these surfaces are exactly that. They are infinitely thin surfaces. They have no thickness. So if I want to make this thick so I could use it to cut, I need to thicken them. So I'm going to say I want to go to Thicken under Create, Thicken. And I'm going to choose all of these faces. And I think I can select them this way. I held Shift. Let me do that again. I'm going to hit Cancel, show you so you see it like I'm seeing it. And I'm going to say Thicken. I'm going to choose this first one in my folder list. I'm going to hold Shift and select the last one. It's going to select all of them in between. And the thickness here should be equal to the kerf of the laser. And if you don't know what kerf means, it's the amount of material that is burned away and incinerated, or incinerated by the laser. And it's pretty tiny. You should do some test cuts and do some measurement, and you'll know the exact kerf of the laser. It's different for each material, so you should figure out kerf for, in this case, medium ply. And for now, I'm going to set this to 0.1 millimeter. And I'm going to say OK. Now what it did is it created, in addition to the surfaces, it created solids that have a thickness. And if I zoom in here, you could see that I have the thickness there. So the next thing I'm going to do is get rid of the surfaces, because I don't need them anymore. I'm going to click on this one, hold Shift, and select the bottom. And I'm going to right-click, and I'm not going to hit Delete. If you hit Delete, it's going to be really annoying, because it's going to delete way back, like where it's going to mess you up. What you want is remove, right? So delete deletes every instance that it ever existed. Remove just deletes them at this point in time, and that's what you actually want. So I'm going to say remove, and they disappear, and I get all these icons now. Each icon is removing a single surface. I wish that this were just one feature, but it is what it is. And now I have all these solids, and I'm going to use those to cut my wood. So I'm going to go back to the modeling environment, which is our 3D solid modeling, and I'm going to say modify combine. And combine is a command that lets you join things together and also use it to cut. So the target, that's going to be what are we going to affect? That's going to be this wood panel, the ply, and then the tool is going to be all of these bodies. Again, I'm going to hold shift and select the last one and select all of them. And then I get to choose operation, and I'm going to choose cut. And the cool thing here is I get to choose if I want to keep these solids, like so that they don't disappear forever, or not. And I don't really need them for anything else. So I'm going to say, okay, they're all going to disappear. And what I'm left with now is this solid body, my wood piece, with my very thin cuts in it. Pretty cool, right? And if I hide, if I get rid of my flat pattern for a second, I'm going to say exit flat. You're going to see here one of these. Hold on a second. I messed up, everyone. I apologize. I completely messed up. So I was doing my work on the flat pattern, and that is not what I should have been doing at all. I completely forgot that I did it differently when I was working on my other files. And that's why right now I do not see anything related to my living hinge. So we're going to change gears a little bit. I'm going to show you how I messed up and how we should do this properly. Instead of activating your flat pattern and doing everything on the flat pattern, instead we're going to have to use a different technique, which is called unfolding and refolding faces. And that's entirely my fault that I overlooked it. So I'm going to do all of this really, really fast so that we can continue on the way that we were supposed to go. And so I'm going to take all of this stuff and I'm going to delete it all because we don't need any of it. It's not going to work. And I'm going to exit the flat pattern, and I'm going to go back to the Sheetmetal tools. And here what I'm going to do is what's called unfold. So I'm going to choose to unfold the sheet metal. And what it's going to do is it's asking me what is going to stay stationary, just like when I did the flat pattern. And that's why it's easy to confuse the two. I'm going to choose this face, and then I get to choose which bends I want to unfold, or I could choose just unfold all of them. And to me, this is going to look exactly like it did before. And then I'm going to go and create a sketch. And we're going to do the same thing like last time. But again, I'm going to do it really fast. And this time I am going to use shortcuts because this was not anticipated and I don't want to waste everyone's time. So I'm going to come in here and do this really fast now. So there we go. Get rid of all of that. Perfect. We're going to draw some new lines like this. Actually, we're going to delete that. We're going to draw this line here, midpoint. Perfect. All right, so this is, by the way, what modeling looks like when you're not doing a webinar and no one's watching you and you just do things a little bit more quickly. Now you know what real designing is going to look like. Perfect. I would ask if anyone out there has any questions at this point, but this is also not a live webinar. You can't exactly do that. So I'm here. We call this in our industry dancing. I am currently dancing for you guys. I hope you enjoy it. I'm trying to fill the audio track while trying to get this done really, really fast. There we go. We're going to pick this spacing right here. We're going to set it to 3 for now. Going to figure out what the dimension is. So this one's called D18, right? I'm going to go and pick these guys. We're going to create a new pattern, just like before. We're going to choose spacing. The quantity is, for now, 3. Doesn't really matter. The distance is going to be equal to oh shoot, I already forgot it. So we're going to cancel. We're going to see what this is again. D18, that was it. So I'm going to do it one more time. All right, don't forget D18, D18. So the distance is now going to be D18 times 2. Everything else is perfect. I'm going to hit OK. Then over here, this is going to be equal to the distance from here to here. There we go. So this is going to be equal to 25.732 divided by, in parentheses, the quantity times 2. And I don't remember the quantity, so I'm going to just say that for now. Then we're going to go back to the rectangular pattern wherever that went. Where did that go? Anyone see it? Nope, of course not. We're going to set this to 3 again. We need to find the pattern. There it was. Okay. There it is. Quantity here is D19. So we're going to come back here, edit one more time, and this is going to be D19 times 2. And now everything looks perfect. So now we could lastly do is go and edit our pattern one last time, choose a quantity that actually makes sense. That's a little bit too much. I think we're gonna go to 5, and now this is looking good. Okay, so while this is being done, we're still in the unfold, refold section. We're no longer in flat pattern because that did not work for us at all. We're gonna go into our patch environment. We're going to extrude. And maybe you guys actually like that I have to redo this because this is giving you a repeat of the same thing. It's a little excruciating for me because I'm doing this under duress, but I hope you guys enjoy. I'm going to take this thing, I'm going to turn it into symmetric, and we're going to drag this pretty big. I'm going to hit OK. I'm going to take all of these surfaces. I'm going to say create thicken. I'm going to choose some thickness here, and I'm going to choose to thicken it symmetrically about the center, and I'm going to hit OK. Then I'm going to take all of these surfaces, right click, and say I want to remove them. Then I'm going to say under model that I want to modify combine. I'm going to choose this target body, and then for the tool bodies, I'm going to choose all of these guys, except for that one. Hold on. I'm going to reselect. I'm going to pick this guy all the way to the bottom, all of those new ones, hit OK. And this looks exactly like what we saw before 10 minutes ago. But now, when I say refold, everything refolds properly. So this is where you'd want to do it, under the unfold, refold. Okay, and what that's going to do here on my timeline, if I hit the minus, you'll see that I have a folder for all of this. This command here did the unfolding. Then I created the sketch for the pattern. Then I created the surfaces. Then I thickened those surfaces, removed the surfaces themselves, and then combined the thickened surfaces with the target, and then refolded everything back. So the only thing I'd want to change at this point is I'd probably want to do a pattern to be able to do the other corners. So I'm going to go back in time by one step. Now I have my folded everything. And I'm going to, if I go and look at my sketch here, I can actually make a new dimension that's going to go from the beginning of this particular living hinge to the beginning of the next. And that distance is 70.732. Perfect. And then I'm going to say I want to make a pattern, but this time I'm going to do a pattern of a feature instead of a pattern of a sketch. So it's under create instead of sketch. Sketch pattern is this one. We're going to do create pattern, rectangular pattern. And this time I'm going to choose features, and I'm going to choose the feature as the combine command that we just used. The direction is going to go this way, and then the quantity is only going to be 2. And we're going to use spacing, and I don't remember the exact number it was from a second ago, but it was something like 70, I think. But it looks like my direction's off, so I'm going to say -70. And when I hit OK, let's see what we get. And it looks like this did not work properly. So let's go back and edit it. And I've seen this before. One of the tricks that I've seen is instead of adjust, try optimized and hit OK. And for whatever reason, that tends to work. Now, my spacing was a little off. So let's go back and look at my sketch to get the exact number. And it was 70.732. So I'm going to go back here, and I'm going to edit this to 70.732. And now, everything lines up exactly where it's supposed to. So that's pretty cool. It does look like we messed up somewhere, and I'm missing one of my cuts that's supposed to be right over there. So let's go back and fix that. Let's figure out why that's a little messed up. We're gonna go all the way back in time over here, and it looks like when I did my surface extrude, I must have missed one. Well, I'll double check actually. Maybe it was in the thickening. And if I show all of these, perfect. Yeah, so it does look like I missed one. So I'm going to go back here and edit this, and I'm also going to choose this line right there. Perfect. Then it also means that when I go to the next step and I did the thickening, I also need to make sure to add that one. So I'm going to thicken everything, including this new one. Say OK. It also means that when I do the remove commands, I also need to remember to remove this new one that just showed up. And then when I do the combine command, I need to also make sure to combine that one that was new as well and hit OK. And now when I go back forward here, everything is looking good on both. Cool. So I only have one last step, which is now I want to do a mirror so that I don't have to do everything on the other side. By the way, you'll notice that when I did my patterning, even within one of these living hinges, the distance that we were doing, we had to do that manually. And you probably also noticed that when I did my distance here, we had to do that manually. And again, it's because I can't use currently driven dimension for patterning or for pretty much any kind of equations. So you have to do that manually. But right now, so far, I've only seen 2 areas in this whole design that we have to do manually. So I'm going to go and say mirror, and this time I'm going to do mirror of feature, and I'm going to mirror both the original combine and the pattern of the combine, and I'm going to mirror it across the center, which I look here is the YZ plane. And I'm going to choose optimize because for some reason that comes out properly. And when I say OK, hopefully I'm going to have a mirror. And that did not work. So we're going to try that one more time. This time, we're going to do the same thing. We're going to mirror the feature. We're going to pick the same things like before. We're going to select the YZ plane just like before. And this time, I'm going to try identical and see if that works. If we see a red pop-up here, it's not going to be good. We don't have a red pop-up, but visually I don't see it actually working. So we're going to go and edit this. We're going to try adjust, even though it didn't work for us the first time. Let's see what we get. And that did not work. So that's a little frustrating. Let's see here. My gut would be that optimize would do the trick. That did not work. So another workarounds are, I would say, the most common thing you're ever going to find in CAD. Something that should have worked, regardless of what program you're using, sometimes just does not work. And that's really annoying, I agree. What's going to be important is whether or not you have the ability to go and fix whatever is not working in another way. So we can come in here and instead of editing features, well, one option is instead of choosing both of the features, I'm going to choose one of them and see if that works. So I'm going to choose the first one and say OK and see if that worked. And it did. Perfect. Then I'm going to do another mirror command, and maybe this time I'm going to select the pattern, and I'm going to choose the same plane as my mirror, and I'm going to choose optimize and say OK and see if that works. And it did. So why I have to do 2 mirror commands instead of 1? No idea. But this is a really easy fix. And so it's just a question of trying other things that could work. Now, if this did not work, what I could have also done is I could have mirrored all of the bodies that I used to combine to do the cut, and I could have mirrored those over, did a new combine command on the other side, and that would also have worked. It would have been a little bit more tedious, but definitely doable. But this definitely works better. And now if I go one step forward after the refold, you're going to see now I have a design that has living hinges on all 4 corners. Now don't forget, this is not exactly for actual laser cutting. This is for visualization of what it would look like. The laser cut part, that you don't want to be cutting using these lines, right? Because the thickness here is actually already taking kerf into account. What you want to do is you want to laser with the original vectors, the ones from, let's see, this sketch that's coming up, like that sketch. That's what you actually want to do. So from a visualization standpoint, what I just showed you is awesome. And the only other thing I'd probably do is go back and edit my original sketch and change, oh, not that sketch, this sketch, and change the gap from 5 to 0.01, something really small. And now when it finishes rebuilding everything, you're going to see that it looks like my entire pattern is closed. I could even have my other body for maybe the top and the bottom, you know, something like you see here where I have a top and a bottom and everything else. If after you've done all this, you would like to see what your laser cut pattern should be, well, there are a couple of ways you can do that. The one that I'd recommend is probably taking, you know, that original sketch and messing with that sketch. So if I look at the pattern that I created here, well, in truth, if you're trying to make your actual laser cut pattern, all of these steps that I use to actually do this with creating the surfaces and extruding, all of that is completely unnecessary. So what I'd probably do is suppress all of those steps because I don't need them. Suppress them. It's going to look like it's a solid, and that's fine because I don't really care. What I do care about is this sketch. And so for this, what I would do is make a pattern of the sketch, make the pattern go across 70.732 millimeters, and then take all of that and mirror it across the other side, and I would export that as an SVG, or sorry, as a DXF into Illustrator. And just to show you what that would look like, actually, let's go and edit that one more time. Right now we have, if I hide the body, hide both of these. So right now we have these lines as projected. I'm also going to project like the top here. We're going to go across. Perfect. We're going to hide this for a moment. We're missing a little bit. Check if we have everything. Still missing some stuff, right? Let's go and fix that. We're going to bring this back. Cool. So I'm going to take this thing, do one last double check. Perfect. I'm going to take this and make it solid, make this solid. Perfect. All right, so now that I have all of this, I could actually take this sketch, which is going to be my master pattern, I'll call it. And I'm going to right click on it and say save as DXF. I'm going to save this on my desktop for now, just as file number 1, just so we can see if this is going to work. I could open up a 2D vector program of my choice, whether that's Illustrator, whether that's Corel, whether that's Inkscape, really doesn't matter to me which one you use. And then Illustrator's coming up, and we'll be able to see what we have to be able to bring over to the Glowforge. Perfect. So here I have Illustrator. We're going to go and open an existing document. We're going to go to my desktop and find all formats. Where is it? 1.dxf. I can choose what my scale is. Now I happen to be using millimeters, so I'm going to choose to scale that 1 unit. I'm going to choose millimeters, 1 to 1 in millimeters. Hit OK. And then in a second here, I'm going to have my pattern of my object. Right? Now, if I did a good job, what you're going to see is the entire outline, and in this particular case, one set of cuts. Now, it is, when you convert to DXF and bring into Illustrator, it is not going to know the difference between construction geometry in Fusion or non-construction geometry. So the dotted line that was horizontal, this one showed up here, and I want to get rid of that. And I also want to get rid of these lines simply by deleting. And if I were to laser this, you're going to have a living hinge in this area that's perfect. Now, before I outputted it, I didn't bother to do a pattern of the other 3 hinges, but if I did, you'd see those here as well. All right, and then this can be saved into an SVG file for the Glowforge. All right, so overall, we covered a lot of stuff today. I'm not sure how long this this actually ran, but I think it's really long. We covered how to create sheet metal parts in general, how to create sheet metal rules, and then how to take advantage of how those rules work to essentially draw open sketches. That's really the key here. Open sketches, and extrude those into a particular length, and that lets you control the exact radius that you're using. All right. So if you go into Fusion and you wanted to make a box like this, you can draw it from above and use that to extrude your shape. Then we showed how to take that and make a flat pattern. We incorrectly showed you how to start making living hinges on the flat pattern. And then we figured that out and realized that what we really wanted to show you is to unfold faces instead of the flat pattern. Right, so the flat pattern is great for your final result for most cases, but in your case, unfold the different bends, then um, create your living hinge, and then only after you're done with your living hinge should you refold those. And I think that's going to be a method that you're going to like a whole lot more. There are some advantages in some cases of doing the flat pattern, but in the case of the Glowforge, I really think the unfold, refold is the way to go. So please try that out. And I hope you have great success in it. We covered a lot of stuff. If you have questions, please let me know. I'm happy to answer questions. I'm sorry that it took so long since our last webinar, and I hope you enjoy this one. We are going to have 2 more. I'm going to do one upcoming about the slicer for Fusion 360, and then the last webinar, I'm not really sure what I'm going to cover yet. But I hope this was helpful. Have a wonderful day. Happy CAD modeling in Fusion 360, and happy Glowforging. Thank you.